In the last video, we managed to connect our MIDI keyboard to our browser, and now we're getting inputs from the keyboard when we're playing it. But it will be nice if we could get some sound also. So when you hit a C, you'll get a C and D, and so you can play music. That's what it's all about, right? So in order to do that, we're going to need to make a little synthesizer, or that's what we're going to make. And we're going to use the Web Audio API for that. It's not going to be like a fully fledged synth. It's just going to be a very simple oscillator, and I'll talk more about that later. But we just want to get some sound when we are playing this thing. We're going to need to get access to the Web Audio API, and we need a new audio context for that. We're just going to look at the window here, our global window, and on here we have this constructor function. Audio context is what it is. If I could spell that, right, like that. And for compatibility issues, it's not a big deal anymore, but let's just do it for best practice. We want to set it equal to itself, right? So if it already exists, if it's already there, we're going to set it equal to itself. Or if it's not there, then we're probably in another browser where it's not called audio context, and that could be a WebKit browser. So we can go ahead and type that in here. So that's going to be WebKit audio context, like so. And let's instantiate one new instance of that audio context. We're going to call that, it's going to be a const ctx for context, and I'm going to say new audio context, like so. And I'm going to save that. So we can see the first thing that we're getting here. The audio context was not allowed to start. It must be resumed or created after a user gesture on the page. So that's, again, I've talked about this before. It's a pain in the butt sometimes if you just want to make some music and you want to play. But it's a good idea that you don't get random sounds coming out of your browser all the time. That you actually need some user input before you can get sound and audio out of your browser. So we're going to take care of that. But in this case, it's kind of irritating. The way we're going to take care of that here, I'm just going to go to the index.html, and then inside our body, I'm just going to make a button here. Very boring and simple. So start context, whatever. It doesn't really matter what it is. I'm going to save that. Going to go back to our app.js, and then right here, I'm gonna get a reference for that. So I'm gonna call it, let's call it start button. And that's going to be equal to document query selector. And we're looking for the button. That's the only button on the page. So now we have a reference to that. And we're going to have to add an event listener to that. So that's going to be the start button, add event listener. That's going to be a click, and that's going to be an arrow function. And what are we going to do in here? Oops, got a space too many here. Just like that. That's better. So we're adding an event listener to this, and we want to start the audio. We want to set up the audio context inside here. So what we can do, we can actually take this one here and copy it and put it in here, because we need access. We need global access to the context. So instead of having this, I'm just going to say let context, because we want to be able to change it down here, and that's about it. So I'm just gonna delete that here. So, oh, that was not correct. Just like that. So we are defining our context here, and then down here in our start button, we are setting the new audio context to the CTX, the one we created right here. So let's see if something is going on here. Well, right now we don't get the error message that we got before. If I click the start CTX button here, something should happen. Actually, we should, let's just try and console log the context CTX, see if there's something there. Let's reload it, and let's click the button again, and we get our audio context, which is awesome. So now we can use that. So in the last video, we wrote this function called handle input, and if the note is on, we will call the note on function that we have down here, and we'll pass it the note and the velocity, and we will turn off the node if it's not. So we have these two functions, and that's what we're going to do something about right now. So here we want to create an oscillator. So every time you hit a node, we want to start up, we want to spin up a new oscillator that will produce the sound that we are looking for. An oscillator basically just creates vibrations as a wave, as a sine wave, so and produces audio like that. So you'll have to give it a frequency and things like that. But we want to spin up an oscillator for every time the node is on. So I'm going to put that in a constant, and I'm going to call it OSC. And we already have access to the CTX that we got right here just before. So it's going to be the context, and we're going to do create oscillator. Just like this. And then we get an oscillator, which is cool. Let's just try and console log this. I like console logging. OSC. Go back to the browser, and every time I have to remember to click this one first. And then I'm gonna, okay. Right now I'm playing my keyboard, and I can see different information here. So here I'm getting the frequency, and I can see the type is a sine wave. Yeah, that's basically what we're getting here. The default value is 440, which is the middle, the A, I think, something like that. You can actually watch another video on my channel where I explain how to get the frequencies from node names and so on and so forth. So you can check that out if you like. I'll leave a link in the description below. But let's go back to the code. So now I want to set the type of oscillator. So I can do that by doing this, and I can set the type property and set it equal to sine. So that's a sine wave, and you can use different types here. You can use a sine wave, you can use a, what is it called? Square, sawtooth. Let me check it out. And I found this nice little article about the different types that you can use in your oscillators. The first one, the basic one that we're going to be using first, is the sine wave. If I click this one, that's what it sounds like. Then we have a square. It sounds a little bit different, right? And then a triangle sounds different as well. And a sawtooth. Very aggressive, I think. So this is like what they look like, these waves here. So this is like a triangle. It looks like a triangle. This is square, and this is sine. It's just, this is the cleanest. I like this one the best. But yeah, we can create different presets for our synthesizer, for our oscillators, so we can change the sound. I'm not going to be doing that in this video. Maybe in the future, in another video where we make a more fully fledged synthesizer. But this is just the basics. So just so you know, we can change that, and we might do that later in this video. Let's get back to the code. So now that we set the type of sine, we also want to set the frequency. So let's just put that on. So that's OSC. We take our oscillator and we put on a frequency. And then on the frequency, we can set the value. And that is going to be equal to, I don't know, right now, let's just put it to 440. Okay, so I'm going to save that. Nothing's going to happen right now because it's not going to play anything, but we want to connect it. So we want to take the oscillator and we want to connect that to the destination. So the destination is on the audio context. So that would be CTX destination. And basically this is just our output, my computer output, my speakers. So I'm taking the oscillator and I'm connecting that to my speakers or to my computer output, audio output. So that should produce a sound. So we can go ahead and we can save this. Let's go back to the browser, this one here, and I'm going to click the button, and then I'm going to start playing. Nothing really happened. Okay. And of course, nothing happens because I haven't started the oscillator, which is stupid. So we can do that like so. Okay, now we should get a result. Let's try, click the button. That was terrible. That was very, very bad. It was way too loud. We only get one sound. We got a lot of clicks, and wow, that did not sound good, but it worked. We actually got some sound out of it. And I can try just for fun. Let's try to take this 880. That should be the octave above, which will probably sound very bad. So that's another sound, that is the octave over 440. We don't want to play the same note every single time we hit a key on the keyboard. So we have to find a way to convert the MIDI numbers that we're getting to a frequency. Let's go all the way to the top here and add that function, because we want to be able to do that. So I'm going to make a function up here. I don't know where to put it. Let's just pull this together right here maybe. Well, it's going to be a function, and I'm going to call it MIDI to frequency. MIDI to freq, like this. And we are going to pass in like a MIDI number here. And then inside our function, we will set a constant here. And we want the A, because the reference node is going to be A. Sorry, this is not correct. Const A is going to be equal 440, and that is hertz. And then we're just going to return okay, and I'm not even going to try to explain what's going on here, because I haven't looked into it myself. I was in a hurry, and I just looked it up online, and it works. You know, if you pass in your number here, it'll take 440 divided by 32, and then multiply it by 2 to the power of number minus 9 divided by 12. It works. If you have an explanation for why it works, then please add a comment in the comment section. I would love to know that. So let's try to actually pass in a number here. We go back here into our note on, and remember we have the note. So I'm just going to take, instead of setting it here, we're going to call our MIDI to frequency, the one we just created, and we're going to pass in the note. So that should be it. Let's try and listen. I'm going to press the start button again. I'm going to press a G. Oh, we didn't get anything here. So frequency set a value outside nominal range. So I made a mistake here. Yeah, we need another parenthesis here. Another set of parens around here. Okay, that should do the trick. Let's try again. I'm going to start. Okay. Okay, that doesn't sound good. First of all, it is totally distorted, and they're playing. There's no way to stop the sound again. And when you play more than one sound, it's pretty distorted. It doesn't sound too good, and that's because the volume, the gain, is all the way up. So that's another thing we want to check down here on the note on. First, we set the frequency here, but we also want to create a new gain. So I'm going to make another up here probably, and I'm gonna call that OSC, so OSC gain. That's an oscillator gain. So now we're creating another gain node that we can use to turn up and turn down the volume. So that is on the context, the audio context, and it's called create gain. And then we get a gain, and then we can take this OSC gain and we can give it a gain value. So we need to go to the gain and then value, and we can set that. I'm gonna set it to 1.33, so it's not as loud. So actually, for every time we hit a key, we are going to set the base value for this, because otherwise it's gonna go crazy and distort. Like, yeah, it's not gonna sound good. In order to take this, we need to connect everything, because right now we're just taking the oscillator and we're connecting that to the destination. So what we have to do down here, we have to take the oscillator and we have to connect that to the OSC gain, the gain that we just created here. And then we take the OSC gain, and that one we will connect to the destination. Okay, let's try and see how that works. That sounds okay, but it's still a little bit distorted. So maybe that's because, so every time we're not using the velocity at all. I didn't hit the keys really hard here. So, but let's just keep this for now. So far so good. We also need a way to stop this, these oscillators, because we don't want to play them forever. So inside our note off function, we need to actually shut off the note that we are releasing. Remember, we get another MIDI event when we release the note, when we want to switch it off. But we don't have access to the oscillator down here. So we need to have like a way we can keep track of all the different oscillators that are running at the moment. So I'm gonna put that in all the way up here. I'm gonna make another constant, and I'm gonna call that, let's call it oscillators. And I'm gonna set that to be an object, because for every single oscillator we create, I'm gonna use the MIDI number, the MIDI name as a property, and we're gonna put that oscillator node on as a property in this object here, so we can keep track of what is playing, what is not playing, and which one should be switched off. So right up here, we're gonna take the oscillator that we're creating here, and we're gonna put it on that object. So the object is called oscillators, and then we're going to use this bracket notation because we want to take the note, and that has to be a string. So we can't just use a number here. Well, that's not that one I want. I want to pass in the note here, and I want to set that equal to our oscillator that we're creating in this moment right here. But as I just said, I want to take the note and I want to run a toString method on it. Like so. Okay, so every time we press down a key, we can actually see what's going on in the oscillator. So let's try and console log this. Oscillators. Click the button here. I'm gonna play some music. Just gonna go back and save to turn off the sound. But if you notice that every time I hold down a key on my MIDI keyboard, I get an updated version of the object that we're putting all the different oscillator notes on. So we're keeping track of it. So so now we actually have access to that in the note off function. So let's go there, and in here, we're gonna make another constant. We're gonna call it oscillator as well, because we want to get the oscillator. So we know that it's already on the oscillators here. So let me just, take this one here. And so we go to the oscillators, we take the note that we're also passing in here, we make a string out of it so we can access it, and now we have access to the oscillator that is running right now because we're passing in the note. Actually, when we release the key, we're passing in the note that we want to get rid of inside this oscillators object. I hope this all makes sense. Then we can just take this oscillator and run the stop method on it. Let's try and see if that works. I'm gonna go in here, I'm gonna click the button, and I'm gonna start to play some music. Wow, so they're still added. It works now, right? I can play different sounds, but I get these oscillators, I get a lot of different oscillators. We need to delete them as well, but at least we know which one it is that we want to turn off when we release the button. So if I go back to the code, first I want to delete the oscillator from the object. So I can do that by using the delete keyword, and I want to delete it from oscillators. And inside this oscillators, I want to delete exactly the same as here. Maybe I should pull that out in separate variables, but I'm not going to do that right now. Or actually, we want to take this after we stop it. We want to delete it not before we stop it. We want to delete it after we stop it. So let's put it down here. And after we delete it, we're going to console log, and that's going to be our oscillators object. Okay. So let's check it out now. I'm going to hit the button again, and I'm going to start playing. So I'm going to hold down 1, 2, 3 keys. Then you'll see what happens. 1, 2, 3. I'm going to let go. And now we have an empty object. So all the notes that are playing at the moment will be present in this object. But when you let go, they will go away. And you can probably hear that you get like a weird little click every time you, not every time you start a sound like this, but every time you let go. And that is because of the human ear. Let me go back to this one here. I'll just explain it to you. When you start an oscillator, when you play it, you start from 0 here, right? and then you have a wave going up here. So if you stop it when it's right up here or when it's not on 0, then your ear will hear that weird little click. So that's something that we're going to take care of pretty soon. Let's first figure out how we actually use the velocity as well, because we don't want to play it for full volume every time we hit a key. We actually want to be able to control the velocity, how hard we hit the keys on the keyboard. So in order to do that, up in our note on, we already have this gain here. We also want to get a velocity gain. This is just like a gain. We put like 33% of the maximum gain just so it doesn't distort too much when we're playing many notes at the same time. Let's add another gain here, and we're just going to do it right here. So we're going to call it velocity gain. And of course, that is going to be the same thing as we did before. We are going to the context and we're going to create gain. But in order to create the gain, we need to, as you can see here, we have a gain. It goes from 0 to 1, right? So we actually have to, the numbers that we get in here, the velocity, that is a number between 0 and 127, right? So we have to convert that number into something that the audio context or the create gain node will understand. So up here, before we create this one, we want to get the velocity gain amount. So I'm going to set that const velocity gain amount. And that is going to be equal to like 1 divided by 127. We want to multiply that by the velocity. So that will give us a number between 0 and 1 that corresponds to the number between 0 and 127. So we can use that. That means that I can go ahead and I can set the velocity gain, and that is on the gain, and that's a value. And we're going to set that value equal to the velocity gain amount, this one here. I hope this all makes sense. Maybe it's going a little bit too fast. I don't know. But let's check it out and see if it works. Well, actually, I know it's not going to work yet because we haven't yet connected anything. So down here where we connect everything, we want to take the oscillator, we connect it to the oscillator gain, and then we take that oscillator gain, we connect that to our velocity gain, this one here. And then we do take our velocity gain, this one here, and we connect that one to the destination. So let's try and see if that will work. I'm going to go back to the browser, back to our program, click the button, and then I'm going to try to play around here. As you can hear, you cannot see what I'm doing right now, but I am I'm playing my keyboard gently first, and then I'm hitting the keys a little bit harder. And that works. Now that is working, we can try to take care of the weird click that we're getting that I explained before. A way to get rid of that irritating click is to fade out the oscillator as soon as you let go of a key. Just fade it out really fast, then your ear will not notice that. But in order to do that, we also need access to the gain that we're putting on here. Remember, we have this oscillator gain here, and we want to put that on our oscillator actually. So before we add it to the object, the oscillator's object, I'm just going to put it all the way down here because we don't want to add it until it's ready to be added, right? This will still work. I can go to the browser and I can still play around, right? Something is wrong. That's because we are console logging. It should of course be console logged after it has been added down here. So yeah, so that should still work, right? As it does. Okay, so we want to take this gain that we are creating up here, and we want to put it directly on the oscillator before we put it on the oscillator object. Because then we can use that down here in the note off, because we need to know the amount of gain that this one has so we can fade it out. So just before we add it to our object here, we can take our oscillator and we can add another property on it here. This is our own custom property that we are going to put in the gain node that we created up here, and that is the one called OSC, oscillator gain. So we can put that here. That way on the oscillator that we get access to here from the oscillator's object, we can find that on there, and then we can use it later on. So let's see what that looks like. Oh, we cannot do it right here. I just want to console log the oscillator here. OSC. So I'm just gonna click the button, hit one key, and then I get this oscillator node right here. And I can see that I have actually, see, this is the one we tagged on. This is just our own custom thing. And so we put on the gain node here. So we are going to use that in the node off function here. So let me delete the console log here one more time. And in our node off, before we stop anything, we are getting the oscillator first. So that now we also want to get, because we know that we tagged on the gain node here, so we just want to pull that out in its own separate variable. So const, let's call it OSC gain, as we did in the other function. And we're going to take that off the oscillator and gain, right? So now we should have access to that. Then here is where we are going to fade it out. So I'm going to take the oscillator gain here, and I'm going to access the gain on it, and that has a function or a method called set value at time. And this one will take the oscillator gain value. Oh, okay. And then we are going to pass in the current time from the context, from the audio context. So that's going to be CTX and current time. And then we are going to fade it out here. So OSC gain, and that is also going to be the gain. And then you can use something called exponential ramp. I'm just going to paste this in. This is a crazy long name, you know. And exponential ramp to value at time. So we can ramp it down to something else. So we're going to start here, 0.0001, and we're going to pass in the context current time, that's right now. And then we're going to add to that 0.03 seconds, something like that. That should take care of that. To be honest, I don't really understand exactly what is going on right here. I found it online and I decided to try it out, and it worked. And that is not, that's not cool that I cannot explain exactly what's going on here. But this is kind of new to me. I just getting started with the Web Audio API, so you have to bear with me. But I'm gonna leave a link in the description, or if anyone knows, you can please explain to me what is exactly is going on, why we need this one here. I'm not totally sure about that. There's not a lot. Oh, that's wrong. I could see there's not a lot of good information on the Web Audio API yet. It's kind of weird, but let's go ahead and let's see what happens here. I'm gonna start the context and then I'm gonna play. It sounds to me we still have that irritating click sound. So why is that? Let's try and delete, just comment out this stop here. And let's try and play again. Wow! It actually works. And so on. So it actually works right now. So that's cool. And why was that? That's of course because this one takes a little time. So this one will, the JavaScript doesn't care. It's just going to continue, and it's gonna run this stop method on the oscillator before it has even faded out. So we're still gonna stop it before it has faded out, and we're gonna get that stupid click. So a way to mitigate that is actually just add a set timeout. So I'm gonna set a timeout, and that is of course going to be a function, arrow function in this case. I wanna add when should I fade it out. I am going to wait about 10 milliseconds. And then I'm going to stop it, because then it should have faded out already. So I'm going to put that one in here. And now it has stopped. So let's try again. So it works. It still works. Oh, there's still a little bit. Let's try and put in 20 or something like that instead. So, oh, that was not correct. I have to click the button. So now it works. That's better. I was also very much in doubt about how it's I don't want all of these oscillators running all the time, so I need to garbage collect some of this stuff here. And I think that stopping them should kill them and get rid of them, but I know that they're definitely thrown out if you disconnect it from everything. So that's another thing I'm going to do. I'm both going to stop it, and then I'm going to take the oscillator and I'm just going to disconnect it. And that means it just disconnects from whatever it's connected to. So that should work as well. So right now we actually have something that that kind of works. We have a synthesizer, so I can play music, and we can try to change the sign to like try square. Let's try that and go back. That's very loud, but it's there, so you can go ahead and you can play around with this. It will be cool with a user interface where you can turn the volume up and down, where you can select your MIDI interface that you want to use if you have more than one connected, where you can, you know, change the type, the wave type, if to square, sine, whatever, and add some effects to it. You could also add, using the Web Audio API, you can make equalizers, things like that. You can add delay. There are so many things you can do. This is like very simple beginner stuff. I hope you liked it, and I hope you get some fun out of it. See you next time. Bye-bye.